All right, let's dive in. Today, we're going to crack the code on a shape you probably think you know inside and out, the isosceles triangle. But trust me, it's hiding some seriously powerful secrets that are the key to solving all kinds of geometric puzzles. So, let's get to it. So, take a look at this. Seems pretty simple, right? But what if I told you there's a hidden relationship baked right into its DNA, a secret connection between its sides and angles that just unlocks everything? You ready to find out what it is? Okay, first things first, let's get our official intel. The textbook definition says an isosceles triangle is any triangle that has at least two sides that are equal to each other. Remember that part. That simple rule is the master key that unlocks everything else we're about to talk about. And that brings us to secret number 1, which I like to call the power. This is a game-changing idea. It basically says that if you know two sides of a triangle are equal, then you automatically know the angles opposite those sides are also equal. This one little fact is, well, it's incredibly powerful. So how do we know this is true? I mean, you shouldn't just take my word for it, right? Let's prove it. Here's our setup. We've got a triangle, and we're told that side AB is equal to side AC. Our mission, should we choose to accept it, is to prove that angle B has to be equal to angle C. The proof itself is actually really elegant. Check this out. First, we're going to draw a line AD straight down the middle, so it hits the base at a 90-degree angle. What that does is split our big triangle into two smaller right-angled triangles. Now we just compare them. We were already given that the longest side of each, the hypotenuse, AB and AC, are equal. And, well, they obviously share the side AD. Because they're both right triangles with that setup, we can use a handy rule called right angle hypotenuse side, or RHS for short. This rule proves that the two little triangles are perfect copies of each other. They're congruent. And if they're identical triangles, then all their matching parts have to be equal, which means angle B must be equal to angle C. Boom, code cracked. So what's the big takeaway here? It's this. If you see a triangle with two equal sides, you instantly have the power to know that their opposite angles are also equal. No questions asked. That is a massive shortcut when you're solving problems. But what if it works the other way around? It does. And that brings us to secret number 2, the tell. This is just the reverse of what we just learned. If you can spot two equal angles in the triangle, that is the dead giveaway, the telltale sign that the sides opposite them are also equal. Naturally, we've got to prove this one too. So let's flip the script. This time, our mission starts with a different piece of intel. We are given that the two base angles, B and C, are equal. Our job is to prove that the sides across from them, AB and AC, must be equal too. And the proof is just as slick. We use the exact same move as before. Drop that line AD down the middle. So here's what we know. We're given that angle B equals angle C. We know that both angles at D are 90 degrees. And, just like before, that side AD is shared by both triangles. This setup lets us use another tool from our geometry toolbox called angle side, or AAS. That proves, once again, that the two smaller triangles are congruent. And if they're identical, well, then their corresponding sides, AB and AC, have got to be equal. Simple as that. So, the takeaway here is super clear. Spotting two equal angles is the tell. It's the little sign that shouts at you, hey, the sides opposite me are equal too. It's really just the other side of the same coin. And when you put them side by side like this, you can really see the beautiful symmetry, can't you? The power says, if you have equal sides, then you get equal angles. The tell says, if you have equal angles, then you get equal sides. It's a perfect two-way street. Okay, that's enough theory. The real fun is using these secrets to crack actual problems, right? So let's put our new knowledge to the test. Time for a field mission. Here it is. Here's our target. At first glance, this figure looks kind of complicated, but our mission is simple. Use what we now know about isosceles triangles to figure out the value of that angle labeled C. Let's break this down. For step 1, just look at the big triangle, ABC. See those little hash marks on sides AB and AC? That's our clue. It means those sides are equal. So we use the power, which tells us the opposite angles must be equal too. So angle ACB is also 80 degrees. See? Easy. Now for step 2, we find angle A. We all know the angles in any triangle add up to 180, right? So A plus 80 plus 80 equals 180. A little quick math, and we find that A is exactly 20 degrees. Okay, step 3. The diagram itself shows us that the line AC is cutting that top angle perfectly in half. That means angle B has to be the same as angle A. so B is also 20 degrees. And that leads us right to the final step. We just zoom in on that smaller triangle ADC. The angles have to add up to 180. We have B, which is 20, plus our target C, plus the other base angle, which we figured out is also 20, and all of that gives us our final equation to solve.
And by following that chain of logic one step at a time, we've isolated our target. A little bit of simple algebra and the code is cracked. Mission accomplished.
The final answer is C equals 140 degrees. How cool is that? You see how those two simple secrets let us completely unravel a problem that looked way more complicated at first?
So let's just step back for a second and appreciate the blueprint we've just uncovered. This really isn't just about triangles. It's about learning to see hidden connections and using pure, simple logic to solve problems.
So here it is, your official Isosceles codebook, ready for action. Secret number 1, the power. Equal sides will always give you equal opposite angles. And secret number 2, the tell. Equal angles are a dead giveaway for equal opposite sides. If you master these 2 rules, you have the blueprint for solving a ton of geometric puzzles.
But really, these 2 ideas are just the beginning. They're foundational tools that you can use to build even more complex ideas. So the real question I have for you is, now that you have the code, what other geometric secrets are you going to unlock?